Let's look at an example of applying Tresca's yield criteria. So suppose I'm given a state of stress sigma, which is equal to beta times this matrix here. So 1, 2, 0, 2, 3, 0, 0, 0, 5, and the units are going to be KSI here. And let's suppose that the yield stress of the material in question is 20 KSI. And let's determine the value of beta that will cause the system to yield. So we can think of beta as a loading parameter on the system, which is increasing the state of stress at some given point in the system here. So if we're going to apply Tresca's yield criteria, what we're going to need to do is draw Mohr circle. So we'll go ahead and put the axes for the Mohr diagram, so the normal stress horizontally and the shear stress going down. And then the first thing we'll go ahead and do is we'll plot the center of the circle, so in the XY plane. So looking down the Z-axis, the center of the circle is going to be at 2 beta, so 1 beta plus 3 beta divided by 2 gives me 2 beta. And then, so that's this point here, and then we'll plot the point for sigma xx, sigma xy, so that's has 1 unit or 1 beta normal stress and 2 beta shear stress, so these two components here. So that gives us the first circle for our Mohr circle diagram, and we need to do the 3 circles of stress. We have to do the full 3-dimensional state of stress. And notice that 5 beta is actually a principal stress because there's no shear on the 3 plane here, or the Z plane. So I can go ahead and plot 5 beta as a principal stress, and now I can complete the diagram by connecting all the intercepts on the horizontal axis with the 3 circles here. And so the maximum shear stress is going to sit down here at this point. So we can calculate easily now. So tau max is equal to 5 beta minus the value of this point over here. So that's 2 beta minus root 5 beta, which I get simply by noting what the radius of that circle there is, divided by 2. So that comes out to be 3 plus root 5 beta divided by 2. And tau max, according to Tresca's criteria, so this is tau max overall, has to be less than tau y, which in this case is 20 KSI. So I can solve this inequality now, and I can write down that beta has to be less than 40 over 3 plus root 5. So this is a simple application of Tresca's yield criteria, and the application is always relatively the same. You have to figure out the radius of the largest circle on the Mohr diagram, and that then allows you to determine whether you have yield or not in the system.